Hello, thank you. I'm going to present you some work that we carry on with Andreas Herzig and Elise Perrotin on the new dynamic epistemic logic, parallel propositional assignment and observation with constants. Oh, does it work? Okay. So first, let's introduce the language of a static epistemic logic of observation constant that we call DEL-PPAOC. First, given a countable set of propositional variable prop and a countable set of constant CST, and a finite set of agent, we define a set of observability operators. In fact, we have SI stands for individual observability of agent I, and GS is jointly seeing, that stands for joint observability of all agents. Then we define a set of all atoms, which is a sequence of observability operators followed by a propositional variable, or a set of non-empty observability operators followed by a constant. And finally, the subset of all introspective atoms is given by every atoms defined by a sequence in which we have subsequent, immediately subsequent SI for same agent I, or jointly seeing operator. So we define the atomic consequence between observability atoms as beta is an atomic consequence of alpha if and only if alpha is equal to beta, or there exists another alpha prime, an atom or a constant, for which there is a sequence of observability operators such that alpha is GS alpha prime or beta is sigma alpha prime. So we say here that alpha is the cause of beta is a consequence of alpha. And we denote by this arrows the set of causes or consequence. So we have the grammar of DEL-PPAOC, which is like the grammar of propositional logic, given that alpha ranges over our atom from observability atoms. And the semantics is given by alpha is true in a state V if alpha is an introspective atom, or alpha is a consequence of beta from some beta in V. So to define our logic DEL-PPAOC, we have the dynamic operator diamond pi, where pi is a program as in DLPA, but we had two new compositions, which are the inclusive non-deterministic choice compared to the exclusive one in DLPA, that is execute P1 or P2 or both. And we have another operator, which is the parallel execution of P1 and P2. So quickly, the semantics of DEL-PPAOC, and we focus only on one interesting thing, which is the assignment. The assignment is given with three. The semantics of a program is given by a ternary relation, where V is the initial state, U is the destination state, and W are the assigned variables. So when doing an assignment in a state, we only add alpha if assigning the truth value of phi to alpha, we add alpha to V if phi is true, or we remove all the causes of alpha if phi is false. And now we focus on the parallel composition. The parallel composition is done by splitting into two states and then merging. So for example, for the initial state where we have P jointly seeing P and I sees Q, we split into two states. and doing on the left, P is assigned to false, and on the right, SIP is assigned to false. And we see that, so we have the W, the variable which are assigned, and we remove, for example, on the left, we remove the causes of SIP, and finally we merge in order to obtain SIQ. So we defined an action with our logic, which is a couple of precondition and effects, where the precondition is a formula and the effect is a set of conditional effects, where given a condition, which is a formula, we have a set of positive effects, and which are atom, and negative effects. And here we have an example in the gossip problem. So for the action call, when I call J, all the secret, if all the secrets, for all the secrets SK which are constant, knows by C seen by I, the secret are seen by J, and conversely. So given this definition of action, we define epistemic planning with DEL-PPAOC, defining a transition function, a partial transition function on states, which is, we remove all the conditional effect, negative effect, well, when the conditions of the effects are true in V, and we add, we remove all the causes of this conditional negative effect, and for all the positive effect, we have we add the effect. And we see that we can capture this transition by a program in our logic DEL-PPAOC. And now it's very short to present this. So if you want to, you can come to the poster session, and I will explain you how to define sequential or parallel planning with our logic. In conclusion, we just here have extended the logic LO, which we have previously introduced in a journal paper given here, and extended to our logic DEL-PPA, the dynamic logic of parallel procedure assignment with epistemic atom from our logic LO. And with this, we can do sequential or parallel, bounded or unbounded epistemic planning easily. And the complexity, we have to prove now that we think that the complexity of this epistemic planning is p-space complete because of the structure of our logic. And that's all. Thank you. If you have a question, or you can come to the poster session. Thank you.